Today is gonna be a little shorter than usual, because we're only getting our feet wet, so to speak. And our goal for today is just experiencing writing actual programs, running those programs, and understanding how to debug them, how to understand the messages we get from the compiler and from the runtime when something doesn't quite work out, and how we can spot those mistakes and fix them. To start with, if you want to start programming, you don't need to start by downloading some fancy compilers, editors, IDE setups, whatever on your computer. To just get started with programming, you can use online compilers. Just search for C# compiler, editor, online, whatever, and you will be bombarded by thousands of options. I exaggerate, but there's a dozen different variations I've seen already. At least a dozen. And they all pretty much work the same, so you can just pick and choose whatever you want. There's not too much difference between them. Mostly it's just visual, and in the end they all allow you to write code in your browser and run it and see what happens. No big fancy UIs and programs. There are limits, of course, but to just get started with programming, perfectly fine. Perfectly valid way to start programming, so that's what I'm gonna use for these first few streams as well, while we're getting used to programming in general. Specifically, I'm using one called OneCompiler, but again, they all are pretty much the same. You can see here, I just have this big text field where I can type stuff in. This is where I write my code. And let me just hide that quickly. Up here, you have the big red button Run, which I can use to run my program, which just means compile and then run it. Though I'll just keep that hiding. We don't care about the blue one, and we definitely don't care about the green one. Now what happens here is, the code I write is stored in a file called beginnings.cs. That's very similar to what you would do in... I was attempted to say real programming, but this is real programming as well. This is what you would do on your machine as well if you write programs on your own computer, offline, and just compile them. You would write code just as a text file, and that text file is just called .cs instead of .txt, for example. It's not necessary to do it that way. You don't have to use CS files, but it's common to use them, and most compilers will prefer you call that CS. But that's not the only way to do it. And the compiler now is a program that takes whatever we write and tries to rephrase that in a way the computer understands. Going back to our very first episodes, essentially we break down our high-level code into lower-level code, into assembly, which then in the end gets turned into machine code for the computer to execute. And this turning high-level to low-level, that's the job of the compiler. Completely standalone program that just takes our stuff and converts it into some other stuff. And this other stuff can be a file that you can execute. It can be a binary file or executable file, depending on what architecture you compile for, because compilation works different for different computers. Again, going back to our very first episodes, high-level languages have one of the advantages of high-level languages, or higher-level languages at least, is that we don't have a specific computer we write the computer code for. We write a more general version of the code, and then we can compile that into specific code for different computers that all have their own little quirks and differences. In C# as well, You can compile it for different computers, which primarily means you have to decide if you compile it for Windows system or a Linux system or a Mac or something entirely different. And in this case, because it's in a browser, we don't really care. That's the wonderful thing. Though I think it's compiling it into an executable and executing that Windows-like system. This program, this compiler that turns the high-level language into lower-level languages, into assemblies, will have sometimes trouble understanding what we want. If we make obvious mistakes in our code, the compiler will not be able to turn this into a functioning program. And so it will abort. It will stop turning our code into assembly, and it will give us an error message telling us exactly where we messed up. Or at least it usually does, but sometimes it's not the most accurate way. We might get to see that today. To start with, I'm gonna leave my file completely empty and I'm gonna compile it. Well, the file itself doesn't look different, but for one compiler we have a little output. Let's ignore that one. On the side here, where we can see the error message we get from the compiler. This on top, let's ignore that. We only care about this down here. This is one possible error message you get from the compiler. The compiler, that program will itself give you messages, information about what it's doing, which of course includes error messages. And for C#, errors are usually, well, numbered, ID'd, not sure you call it labeled. You have error codes for specific types of errors. So you have an error and an error code, and this means one specific thing. And then you have some text giving you some more details. Sometimes those details aren't really helpful, and in other cases, they are the entire point of the message, because the error code could be anything. Right now, it complains that we don't have a static main method that we can use as an entry point. That's what we talked about last time. When we start a computer program, we need some way to start everything, to get it going. We need an initial method to run, which itself then determines what else to run. That was the main method. So we needed static method because we didn't have anything on the stack or the heap to call methods on, so it needs to be static. We don't need any return values. We also don't need any parameters. And the method itself is called main. Now something you see here, I type in the opening bracket, I just hit enter and it will automatically add this closing bracket. That's one of the features you get when you use IDEs. And even though this is a very simple compiler, there are a few things it does that are helpful. By the way, I've turned the autocomplete off, in case you're wondering, for good reason. We're learning stuff, I don't want the IntelliSense here to mess with what I'm trying to tell you, to distract. You can also see that if I bring my cursor to one bracket, you will see a little box around it, and you will see the same box around the matching bracket. So if I'm at the opening bracket, it will also display the box at the closing bracket. If I add another pair, see? Opening, closing, it's always highlighting the matching partner for normal brackets as well, which is quite useful. Those are pretty standard features, by the way. You will have that in most editors. Big IDs, definitely. Small IDs sometimes have less features, naturally, because they focus on some other goals. Alright, so we have in the main method. Let's try to run it. And we get a different kind of error message now. Now the first thing we should look at is we now have something before. How do I get back? Okay, that's something I have to get used to. I have to be more careful with my key inputs than my clicks, because this is a browser now, so be careful. Alright, so we see something before the error message. We now have beginnings.cs 1,7. Beginnings.cs is our file we're currently in. Alright, so what do these numbers mean? 1 and 7. When the compiler finds a specific issue somewhere in our code, it can give us the exact location where it found the issue. So there's no misunderstanding about what it's complaining about. And it's doing so by using the row and the column. Imagine that your code is just a large table. We have 1 row, 2 rows, 3 rows, 4 rows. And each row we have columns, which is just characters. 1, 2, 3, 4, 5, 6, and so on. Loses kind of meaning if you don't use monospaced fonts, but those details. The column value isn't always the most correct, but the row values are fairly reliable. So it's complaining right now about an error in line 1. Right, so up here we have an error. And it's saying unexpected symbol void. And listing a couple of keywords that we haven't even talked about yet, which we don't need to talk about so far. The reason it's complaining now is because we just have a method, but methods cannot be on their own. We need something to enclose that method, something to contain that method. We don't have a class yet, or struct. Well, I'm usually going for class. Just call it program and close the brackets down here. And let's shift this over a bit. Readability. Right, so now we have an actual class, which internally has the main method. Let's try running this again. And this time we didn't get any errors, and this is not the compiler output. This text right now is just the online editor here letting us know that there was no output. Which is correct. We didn't output anything. We're not going to output anything for quite a while, so this is expected. This just means everything worked. We were able to compile the program, and the program was successfully run. Great. Now we have a starting point to write code. So I can just do code we already did. A equals 2 and B equals 2 and C equals A plus B. Another feature of compilers you might be able to see now. On our brackets here, you see there's a red line giving us a clear indication for where we can find the matching partner, which is more important once you have a lot of code. You can see red line here connecting the two. And talking about colors, if we look at these numbers, the integers 1 and 2, I'm not sure how well it is visible in the stream, but they are different color than our text. They're slightly bluish. Turquoise, maybe? Compared to the text, which is just black. And the text itself has also little differences, even though it's black everywhere. You can see if you compare these two, this is bold, this is normal. Bold, normal. Bold, bold, bold. This is an example of what's called syntax highlighting, which is also something most editors offer in some way, and definitely bigger IDEs will offer it. It's a way to help you organize the program more easily. If the text looks the same everywhere, it might be difficult to find specific parts, just identifying where you want to go, where you want to look for something. But by giving it slightly different look and feel, you can more easily distinguish between different parts of your code. This is a keyword, so it's this and this, so they're bold. But this is just a name I gave it. So they are not in bold, just normal font. This is not text, these are integer values. They have a specific meaning. They're not simply characters. So we give them slightly different color from normal text. Again, just a small example here, and different editors will do very different things. The way the syntax highlighting works is there are really no standards. You can do whatever you want. Certainly editors come with a default set of settings for how you want to highlight your code. What colors to use, when to use what font, which properties of the font you want to change, whatever. But you can do whatever you want. Okay, so this is standard code. I run it, no output because no errors. Everything was just fine. Let's try to recreate an error we had in the past. Think back. What is the issue with this code right now? That is correct. I assume we said the right thing. Let's try to see what the compiler has to say. We get, again, a specific location where it found the error, line 7. That's down here. And it says column 11. So if we 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So not too correct. If we get rid of the tabs in front, it will be a bit better, I think. 1, 2, 3, 4, 5, 6, 7. There we go. So the tabs in front kind of break it. I'm a tabs kind of guy. I don't like to do spaces. So that messes with the compiler a bit. You can see the row column. The column information isn't the best, though it is useful sometimes. The row is pretty useful. We know there's an issue in line 7, and the error is specifically we use an unassigned variable, we have a specific error code, and the message tells us specifically which variable we used that we couldn't. A doesn't have a value, it is unassigned. It's not defined what value is inside, so we cannot make an addition between it and another number. Let's get rid of B2. Try again. And this time we get 2 error messages. Both on line 7. And both are identical, just for different variables. And this is output from the compiler. It tells us exactly we made a mistake here. This is not possible. Okay, let's try to recreate some other errors we had, or things that would work. Let's do this. We're adding a new scope, and we're creating B in that scope. We get an error in line 9. We'll just get down here. New error code. B does not exist in the current context. B is defined in this scope only, but no longer in here. We move that up. Program works again. Let's try to mix it a bit. You can see it's not even acknowledging that A cannot be used. Right now it's hiding one error we have with another error. That's an issue you sometimes have to work with. The compiler isn't almighty. It's not giving you a strict list of do this, then do this, then do this. Sometimes it's not able to see the actual error, and sometimes it's not seeing an error at all because another error hides it. So if we go like this, actually let's just remove the brackets. We do this, B is visible again, we solved one error, but suddenly we get a new error. And you might think, my fix broke something. This kind of thing will happen. I mean, it's a simple example, but that kind of scenario will happen to you a lot, where you fix something and suddenly the original error is gone and you get a different error. Your first instinct might be, I made something wrong while doing the fix. I broke something specifically. And that might very well be true. But sometimes fixing one issue just makes an already existing issue visible. It didn't add it, we just made it visible. So now we get a new error message for a new problem that we just didn't know about before, but that was already there. Right, let's try something else. Oh yeah, that was a fun one. I'm creating a struct called val, and it will store another val. We're not gonna create any code up here. Oh, actually, let's do that. Val be equal. It's new val. Remember, this was not allowed. Can you remember why this is not allowed? Well, I'm just gonna run it. Let's see what the compiler has to say. Ooh, interesting. So, we have now two messages, but one of them is not an error. It's just a warning. Let's ignore that for now. Here's the error. Struct number val.another, val.another. So it's using basically the same syntax we would use in code of this type. Causes a cycle in the struct layout. If I were to use class, we have no problem. But with the struct, this is an issue. And if I do struct val2 and store val b in here and say this is val2. So val stores val2 and val2 stores us val. So we don't store we don't store a value of us in ourselves anymore. But we still get the error message. Now we get it twice, because we are still creating this cycle, this loop. We just have stretched it out a bit. Class. Changing this. No problem. So that was a different error message. But let's go back to what we had there. You can see right now it doesn't complain about anything. Let's put that back in and we get a warning. As the name suggests, it's a warning, not an error. We can compile the code just fine, but the compiler is letting us know that this isn't quite right. Something isn't adding up here. Maybe you should check your code. Maybe there is a mistake and you didn't know about it before. It's when a program can technically be run. I mean, right now it cannot be run because of this error with val, but it sees that v, this variable, is added here, but we never make use of v. We never do anything with v. So that means we either, the most likely explanation is that we either left this in here, even though we don't need it, so we just forgot to clean it up, or we forgot to add another line which would use v. Maybe we made a typo and used a different variable somewhere. Like v2 goes in the val, and then maybe v dot. Let's actually change this down here to int I. Let's be creative. I equals v2 dot I. So if you look at this code, it should run just fine. Okay, I forgot about that. Okay. Right, that's something we haven't talked about yet, and I'm not gonna talk about it today, I think. Wait, no, what time is it? Yeah, no. I'm gonna skip that probably. Let's ignore that there's an error right now. If you look at this code, I'm using both a v and v2. Now let's say I forgot to add this to, made a typo and I just said v I equals vi. I completely left out v2, and in that case, the compiler might issue a warning that I've never used v2, and that lets me know, wait, I was supposed to use this second value. Why is the compiler complaining that I don't use it? And so I can check and see my code is, oh, I made a typo. This is supposed to be v2. That's the kind of thing that you use warnings for. There are other types of warnings, of course. A lot of other types of warnings, and they usually just mean you might have forgotten something, or maybe you're just prototyping, testing things. It is perfectly fine to write code with warnings. If you don't really care, then, well, whatever. Like, having an extra variable is usually not a neckbreaker. But they demonstrate often that something else isn't quite right with the program yet, and maybe you should spend a bit more time cleaning that up. So ideally, you usually get rid of all the warnings as well as all the errors. You have to get rid of all the errors because you wouldn't get a program without it. As long as there's an error, the compiler will not finish and you don't get your compiled program. You also want to get rid of warnings because they might indicate something else is wrong. There's a problem here, there's an error that's not visible directly, and the error might just be in the way the program behaves and not in the sense that the program can't do its job. There's also another level of this that IDEs sometimes have, is where it's not directly a warning by the compiler, but it's additional systems that are included in your editor or your IDE, whatever you're using, that have additional checks that go on top of whatever the compiler does. And they might suggest also some changes. Those are very specific though. And sometimes they belong to the organization you work with. If you work with a team, maybe they have some conditions for, we want our code to be structured in this way, and we want this to happen, and these things to be worked out this way. And so they add a list of rules that get applied on top of the existing rules just for basic C#. And that's kind of a warning, but not by the compiler. We don't care about that yet. Some other errors. think I had some earlier. I was thinking of a specific error I wanted to show. I forgot about it already. Oh well. Let's say you write your program, you get rid of all the errors and all the warnings your compiler shows you. You get a finished program, and then when you try to run it, it still breaks. Not because your code isn't correct, but because the logic of your program is faulty. Just because your code compiles doesn't mean that the code is correct. If you want to write a calculator app that's doing subtractions whenever you make an addition, that's perfectly valid code. The computer will execute that just fine, but it's still wrong code, still the wrong program. And so there are types of errors that can happen while the program is running that are not obvious or visible in the code. And sometimes you can't see it in the code. Let's make... What's the classic one? Yeah, let's go for the classic one. And it's 2, let's say... Actually, let's go for that. And in C is E divided by B. Can you tell me the issue we might have here? We divide 1 by 0. What's the result of a division by 0? It's undefined. It's not allowed. You're not allowed to divide by 0. The computer knows that. You could technically still trigger the different circuits that do divisions. At least, well, it depends on what you're using, but you could technically run a program that does division. It's just that the output will not be correct, and the standard solution for C# is that when this kind of situation happens, while a program is running, we cause a very specific type of error. The errors we saw before, error and the warning, were compile time errors. There were fundamentally issues in our program code the compiler saw already. Reasons the compiler saw that would not allow to create a working program. There's also the other side of the coin, which is the runtime error. Things that the compiler didn't see or cannot see because it's not its job, that pop up while the program is running, or that can pop up while the program is running. This is one of them. Imagine that these two are inputs the user makes while the program is running. It's impossible to see that in code. We don't know which values the user will input. We now have the benefit of foresight because we hardcode those values in here. But then what happens during runtime when your program does something it's not allowed to do or it cannot do? Let's run it. We get a special type of error that's called exception. And just a heads up, we will talk about exception at more length and how to deal with exceptions at some point, because there's actually quite a lot to this system of using exceptions, runtime errors. But for now, we'll just deal with what do we do when we see an exceptions. And there's a lot of stuff in here that you usually don't really care about. And the actual code can look very different. For example, because I'm using the online editor, you see this stuff, which is not what we expect to see if you run it on your program, when you run the program on your computer. What we expect here would be the file name and a row number. So instead of this cryptic stuff here, I assume it's a hash of some kind, :0, you would see probably just beginnings.cs :7. So let's just copy that over. So we would see this, but then actually, let's just do it this way. So you still have the output in here for where it happened. Just not visible in our exception because it's an online editor and it handles the compilation a bit differently. So you can see it's doubled up here. We have the same basic thing twice. If you look at this is the exact same text as here. That's a consequence of the specific type of error we caused right now. Ignore that for now, for the next few streams. The only reason I'm putting this ahead of schedule is because you will run into this once you try to write programs, and I want you to be able to understand roughly what's going on. And this thing says it already. Exceptions are always, yeah, in a way we have also an error code again. It's just a name now. Divide by 0 exception. It's a different type of exception, a specific type of error. And we have some text, a message, describing what's happening. We attempted to divide by 0. Makes sense. And it lets us know where it happened. Happened in program.main. So this method of this class, we get usually a file name and a row number, helping us identify where we were in the code when the exception happened. That's important detail. It's not necessarily where the error is. It's not like a compile time error, which tells us there is a typo, for example, in line so-and-so. This means the error happened while the code was executing in this position. So the program already did this and this. We were during the runtime of our program, and then it tried to execute this. And during that execution, it failed. So if we... I can type static void other method. Stuff like this. If I just move that out to here and call that again. Sorry, I should call the method other method. This is not what I expected. Why is it? Did it inline the method or what's going on? Okay, let's try this differently. Let's ref. Well, let's do class C. Let's be class C. It's a static method, so I can just use the class name and call it. Let's try to run it. And now this complains again. Right, I can't show this off without showing you the other thing. That's not good. How do I handle this? Okay, I'm not... Let's do it like this. There are forces at play that force me to twist the code a bit. Right. Nope, it's not doing what I wanted to do. Okay. What I expected to see, what was supposed to happen is that you see not just one line up here, but several lines. See, it says right now the error happened in program.main, but that's not where the program had the actual issue. The actual error happened down here in other method, which was called from other method, which was called from main. We call the main method initially, we start on the stack in the first stack frame, and then we call other method, and we go down on the stack, if you remember, to the next stack frame, to a new table or list of tables, new context, and in here we call other method. We go down on the stack even further, in a third stack frame with its own table. And this is where the exception happened. And when you get an exception, what you usually get, which should be visible, is a list of all the stack frames from the very start to where you are now. So besides program.main, we should also see program.otherMethod and program.other method. All listed in here. Below one another. Add so-and-so, add so-and-so, add so-and-so. It should list us the stack trace, the entire way from the very starting point to where specifically we went, through which way we went there. For example, if I go through other method first or other method directly, that's a difference. I want to know how did this method get called. That might be important. So the stack trace is fairly useful, very important tool for debugging. For some reason it's not shown in here, and I'm not sure why. If I'm just missing something or if it's because of the editor right now. Oh well. Let's go back to clear conscience, clean main method. That's a runtime exception, runtime error. Exception because it's exceptional behavior that's not anticipated. Let's do something else. Say we have int a equals 3 and then we do byte b equals a. We do it like this. We get this error message. Because we are trying to store an integer in a byte, which would lose information. So it's not letting us do this directly, implicitly, automatically. And as it suggests itself, we can just change this with a cast. Right, did I not save this? I feel like it's not running my current code. Ah, right, I made a mistake. Sorry, of course. I have to make explicit cast to byte. That's better. So what happened here is, of course, I made a mistake. I cast this integer to an integer and then had that integer be implicitly cast to byte, which of course doesn't work. I can try this as well. Cannot cast short to byte. Let's do crazy things. Different type of error. Try to cast an integer as a bool. But we do. But why can't I type byte like that? That's fine. Let's try something more interesting. No problem here. We just lost information, but that's fine. Let's see, what can we... I'm looking for interesting errors I can show you that you will run into, or that we ran into in the past. Oh, yeah, that's maybe a good one. Let's go for... Just make a simple class. Ref. Let's not put anything in there, just... We now have type ref. Ref r equals... No, that's not... Nope, can't do that. There's something else you need to learn about first before I can demonstrate that, really. Unfortunately, not possible. That's one I can show you. So, static void out method out int a. So remember the out keyword for parameters. Out method, and I can out int do this, and I suddenly have an a I can work with. Or do it like this and just pass it on. I mean, either way works. Remember how the out keyword means we have to provide a value to return for a when our method returns. Or before the method returns, we have to set something in here. We don't do that yet. So we get compiler error. Must be assigned. So we should do this, and then it's fine. Similarly, when we do this, turn this into a ref, what kind of issue might we run into now? Do we run into an issue? Why? Why not? Answer? Unused local variable a. They're unassigned. We created an a, sort of, but it's undefined yet, and we passed that in our method as a reference. Now, if you remember reference, this int a is pointing to the exact same position on the stack as this does. So you might think that I'm assigning a value to this variable now. Why is this an issue? Well, the compiler does think that's an issue because our model is a bit simplified. And even though we say we have now an integer a on the table, on the stack, that's just undefined, it's not really there yet until we use it. So we pass a reference to nothing. I think of this as the value type equivalent of a null reference exception. This a has no address on the stack yet. It's essentially a null, like for reference types null. So when we pass it on here, where we expect an actual value, we don't have anything to pass on. Looks quite harmless though, with just the unassigned local variable. It is the equivalent of a null reference exception, at least in my head. Yep. And we are there. Actually, does it show that error? No? Okay. Depending on your editor, it might give you a little hint that this is not the best idea. It's valid code. You can just add semicolons, but Usually that's a sign that something went wrong again. Typos, forgot something to clean up. Different things. Other errors. What kind of errors will you run into when you just start programming? At least with the coding we've done so far. Oh, yeah. That's a good one. Let's go... and s equals 0, and then let's do for int e equals 1, I less than equal to 10, I, and we do s plus equals I. Okay. Think about this code for a moment. What does it do? We have a variable s that starts off as the 0, and then we have a for loop that uses the variable I to iterate through. We initialize it before we start the loop at 1. The loop itself will continuously repeat until I is at least 11. So it will continue as long as I is less than or equal to 10. So it will stop by 11, and I say 11 specifically because we increment I after each loop. And then we add the current value of I to s, so we just sum up all the numbers from 1 to 10. That's what this code does. No problems here. What happens now? We made a mistake in our code. Maybe we switched something around. Maybe this was originally meant to count down. Like this. And then we changed our mind and counted up. Or something entirely else happened. But in any case, we start at 1. We will run as long as I is less than or equal to 10. And after each round, we decrement I. So we start with I equals 1, which is less than or equal to 10. We add 1 to s. Then we change I to 0. 0 is still less than or equal to 10. We add 0 to s. Decrement I minus 1, which is still less than 10, and so on and so forth. In theory, this would at some point hit an underflow and start at the very, very big numbers again. In which case this loop will abort, so it's technically not an infinite loop, but it will take quite a long time to run. If you run this on your computer, you can just kill the process. What happens if we do this in an online version? It just will abort. After 740 milliseconds, it simply stopped. Self-protection kicked in. Let's try this again with normal ++, and let's do it just like just a very big number. Wait, actually, how big? Let's see, 3, another 3, 10 million. Also ended fairly quickly. Let's go for a smaller number, just 100. That was just fine. I promise you the 10 million didn't finish executing and computing. It's... Actually, we can test that quite quickly. S equals... I'm not sure if the compiler will catch this. Zero. Split equals n. We cause an exception here. Alright, so we definitely hit this code. Go to 10 million. Still hitting that code. I don't believe you're executing this code this fast. Yeah, no, you're not doing that. So what's happening? I'm dealing with the weirdness of the editor right now. I'm not sure what's happening right now. It's showing the exception, but it should not go there this fast. Or am I underestimating the processing power behind this thing? That's also a thought worth exploring, I guess. Okay, yeah. Alright, let's just double this up. Let's just see what happens. Huh, I guess I'm underestimating the processing power behind the system. That's good to know. Okay, let's turn this into a true endless loop. No way out. Alright, doesn't work like that. Fun. There we go. Okay, now we hit the limit. I'm impressed. I didn't think this online compiler would run the programs this fast. I would expect, like, the speed to be way less than that. Okay. Guess technology has advanced in the couple years I... Nah. Forgot the word. Cool. Okay, but around 5 seconds seems to be then the limit at which it will simply end the program. Your program will not automatically end, most likely, if you run this on an actual computer. If you use an online editor, they will all likely have some kind of runtime limit, though I'm not sure where they stop. The actual computer program on your own machine would simply run forever and you would have to kill the process. That's a different type of error that's not getting us any error messages in any way, and it's simply observe the computer program and see what happens. That's the last class of error. The computer does everything, it's not struggling with anything, it's just not doing the right thing. Which often means it's frozen and unresponsive because of some endless loop. And sometimes it's just a straight up bug where you do an addition instead of a subtraction. Obviously not correct calculator code, but that's not something the automated system can just spot like that. That's a topic for very much later when we talk about testing. Okay, honestly, I think this is where I'm calling it quits for today. This was just, as I said, getting your feet wet, showing you some error messages, seeing how to deal with that, not getting overwhelmed by it. You can just pick out whatever online editor you want and experiment with it. What does it say? How does it respond to mistakes in your code? What are the limits of your editor? Get a feeling for how that works and how you operate it. And next time we will start by looking into the very thing that prevented me from showing you some stuff earlier. Because that's tying into another group of stuff later on anyway. Right, so have a good Sunday. And see you next time.